We're on to 1A.3, rates of change in linear and quadratic, okay? So what we're supposed to learn according to College Board is we're going to find the average rate of change over a closed interval, find the slope of a secant line over a closed interval, use an average rate of change to determine concavity, and write a linear equation for consecutive equal length input intervals that represent this function, represent the rate of change of a quadratic function, okay? So I broke this down into two parts. We're going to start with part 1 today. Okay, so I broke it into two parts. We're going to do lesson 1A.3 part 1 first. And then you should have gotten your 1A.3.2 next. So how it should fold in half and make two little booklets. Yes, hopefully. Yes. It printed correctly and my life is did it? Yes. Yeah. Okay. Woof whoop. So it should fold in half, make a little booklet to start you off. And then we're going to navigate through that booklet. If you saw on your up there, your free response questions, those are your pages 8 and 9 or 7. Hold on, I forgot that quickly what I wrote. This is why I write everything. Yeah. So your free response questions are your 8 and 9. I want you to keep those. As you're doing this and as you're working it, that's going to be your part of your learning. Okay. When I go through and I put in the correct answer, you can check yourself and see what you need to change. But I want you to have this something to reference back to. Okay. So these are going to be pages. Your two booklets are going to be 10 and 11.
You said what?
Part 1 is page 10 and part 2 is page 11. Got it? Yeah. Okay. All right. So we're going to start with part 1. So previously we talked about rate of change with multiple representations. We looked at graphs, equations, tables, and verbal descriptions. Okay. Today we're going to consider rate of change looking at linear and quadratic functions. Okay. A secant line. So your secant line is going to be a line joining 2 points on a function. That's a secant line. Okay. A tangent line is going through a point on a function. It's going through 1 point on a function. However, a secant line is joining 2 points on the function. Okay. And we're going to use the secant line to find the slope of the secant line using average rate of change. Okay. Over whatever that interval is. And you should be comfortable doing that by now, right? Yeah. Okay. So we're going to look here. Consider the graph at the right. This is going to be kind of an Algebra 1 review. So if it feels like I'm going fast, it's because it should be what? Algebra 1 review. Okay. Here we have this lovely linear equation, 3/2 x minus 3. Agree? Okay. How do I know that this is its equation? Well, we know that, but how do I know that this is the equation for this line? Exactly. I have to find the slope and the y-intercept. So let's start with the easy one. Y-intercept. Y-intercept, which equals your b, right? My y-intercept, I'm going to go to the y-axis, and where is it at? -3. So my y-intercept should equal -3, and does it? Yes. Second, I'm going to check for my slope. My slope equals m, equals my rise over my run, my change in my y over my change in x, all those things to represent your slope. Agree? So if I have a graph, I can count it out. I go up 1, 2, 3, and I go over 1, 2. So we rise 3, and we run 2. Does that match the slope of my problem? Yes, that's how you know that that is the equation of that line. Agree? Yeah. Okay. It's a y. They got a little weird in the end. It is. I told you it was. So it is. All right. And so now we are in the form of y equals mx plus b. Correct? We all remember this good old faithful guy. All right. Now it says, what do you notice about the average rate of change? Because of it being a linear equation, is my slope going to change? No. That's what makes it. It is a constant. It is constant. Okay. That's why it's called a constant rate of change when you're talking about slope. Okay, slope is only particular to a linear equation. Got it? Slope only pertains to what? Linear equation. And the average rate of change can be applied to any function, but slope is only for linear equations. That's because slope stands for a constant rate of change. Okay. All right. Let's keep going. How is the average rate of change related to the equation itself? For this problem, we're saying that it's going to be the same, right? So when we're looking at this, when we're going to write this in terms of explaining yourself in free response, we would write for every change in x, the y value, is our y value increasing or decreasing? Increases by our constant rate of change. And what is our constant rate of change? 3/2. That is what our average rate of change is telling us. How are your y changing? So as my x's are changing, my y values are increasing by 3/2. Okay. Now, when it asks you, this is going to be a kind of a slope grid here happening. It says use the grid at the right to sketch a graph of the function representing the average rate of change of the linear function. So what it's asking us to do is to find the average rate of change, which is just going to be 3/2, which equals 1.5. So that means that since it's a constant means what type of graph? Linear, what does it look like? Well, a horizontal, right? So because it's constant, we're going to draw a horizontal line with 0 slope at y equals 1.5. So a constant means horizontal with 0 slope. And for this problem, it's going to be at y equals 1.5. So I'm going to go here and draw the straightest line you've ever seen. Thank you.
Oh, wow.
I know, mind blowing, literally. Yes. Do we remember seeing Hoy in our lives of Algebra 1? Hoy Vux, exactly. Hoy Vux. You see my cuss word in 8th grade in math class. It was my math class word.
Oh yeah.
You know? Yeah. Annoying little 8th grader. It's crazy. Y'all are old.
Oh, wow.
I stopped aging a long time ago. Yeah. All right. So for all linear equations, this is what a sketch of its average rate of changes would be. Does that make sense? Yeah. It would be whatever your slope is, because it's a constant line, right? It's a constant. And so therefore it'd be a horizontal 0 slope, y equals 1.5. So to make sure that we understand that, we're going to do one additional one on our paper. So we're going to do an extra example. If I have the function f of x equals negative 2x plus 3, graph the average rate of change. What would my average rate of change look like? It would be where? It would be a horizontal line at -2. It's at wherever your slope is. And where's our slope at? Huh? I just made up numbers. Not if you feel like you understand it, but I wanted to make sure we were all good.
They just say graph average rate, it's not graph the equation.
Exactly. There's a difference. This is graphing the average rates of change. Okay. So for linears, our average rate of change are going to be constant horizontal lines with 0 slope at wherever your slope is. Does that make sense?
Positive three, since that's the intercept.
Because positive 3 is your y-intercept and has nothing to do with your slope. So it's, so like at any given point on that equation, that linear equation, my rate of change is gonna always be 1.5, 1.5, 1.5, 1.5. 1.5. Yeah, so this is graphing, so this is not comparing x's and y's, this is comparing your x versus its slope. So when x equals 1, the slope is 1.5. When x equals 3, the slope is 1.5. But on the blue graph, it has to be at -2 because what is your slope? -2.
Because the average rate of change on the first one is 1.5, but is this in the negative person or no?
No, I just made up another example to make sure you
The
understood.
average rate of change on the example is what?
The average rate of change is -2.
You graph a line thing.
So you graph a line at -2. Because the average rate of change of any linear function is just a constant function at y equals the slope. Do we get that?
Wait, so what
For
kind of-
any linear function, it is a constant function at y equals the slope. So let's just, for poops and giggles, here we go again. We're not on quadratic. If I have y equals, are we ready? 4x minus 6. And I tell you to graph the average rate of change. Where am I graphing this average rate of change? A horizontal line at 4, because 4 is your slope, your rate of change. Okay, so again, it's linear, so I know it's going to be a constant. Constant means that it's going to be horizontal with 0 slope at y equals your slope. And what is our slope here? 4. So this is where the average rate of change would be.
When it asks the average change, that's when you know to do constant or to do,
When you're graphing the average rate of change, you're focusing on the slope. You're not graphing y equals 4x minus 6. You're graphing the average rate of change of that. Okay?
So what function was the actual question?
Which graph?
The red.
Yeah, but like, was it a linear? or-
It's
These are all
You're all linear. We haven't.
Constant.
Constant is only for linear. Okay? All right. Now we're gonna look at a non-linear situation, because hopefully we got linear down. Yes? Okay, so looking at non-linear, we have a quadratic. Our quadratic is f of x equals x squared minus 6x plus 5. Okay, and the table of the values are given to us, and we're going to find the interval, using the intervals given, we're gonna find the average rate of changes on these specific intervals. Okay, so when I find those average rate of change on those specific intervals, I then can create a graph of the average rate of change. Does that make sense? Okay, and it's no longer linear. So I can't just say it's a constant line. Does that make sense? Because it's a quadratic. Okay, yeah. All right, so for the sake of time, the average rate of change from 0 to 1. So if I look from 0 to 1, am I increasing or decreasing? Decreasing. My rate is going down. It's a decreasing. We read graphs from left to right. So this would be a decreasing situation. To go from here to here, I went down 5 and over 1. So this would be a -5. Agreed? Okay. Now we're going to go from 1 to 2. Again, it's still doing what? Decreasing. So I'm going from 0 down to -3 and over 1. So what is it?
Wait, how did you
Yeah.
I count it down from -5 to 0.
find them?
Rise over run.
How did you start five?
Because it says start at 0. So I went to 0 and the value is 5. Then I went to 1. All right, now we're going from 2 to 3. It's decreasing by -1. We're going from 3 to 4. Increasing by +1. We're going from 4 to 5. And we're increasing by +3. And then we're going from 5 to 6. And that means we're going up 1 and up 5 and over 1, and that's 5. Those are the average rate of change at those specific intervals. Does that make sense? Yes. Okay, so we have two things taking place. On one side, we are decreasing, and on the other side, we are increasing. But notice that your average rate of change is still the same. I'm going increasing by 2, increasing by 2, increasing by 2, increasing by 2, increasing by 2. Do we see that? Okay, so the conclusion here, as the intervals move right, what did we say is happening? The rates are doing what? Increasing by 2.
If you turn in the homework, right?
Yes. Okay, the other thing I want you to point out is that there is a minimum here, and because there's a minimum, what does that mean is happening at x equals 3? The A-rock is what? At x equals 3, the average rate of change is going to be what? 0. Is 0. Max and mins, their A-rock is 0. Max and mins, your A-rock is 0. Yes. If you're done,